Hey everyone, welcome back to my channel, and in today's video I will walk you through how to securely encrypt sensitive data using AES encryption in Python. Whether you are working with JWT tokens or sending secure API requests, this is something every backend dev should know. So let's dive in. And so for you to encrypt data, we need to import some dependencies like hashlib, base64, AES from crypto, pad from crypto, JSON, and also login. So let's start by importing our dependencies. So I will import hash lib. Okay, so this is used to hash strings. So this is used to hash strings. So we will use SHA 256 to derive encryption keys. Then the next thing we are going to import base64. So this helps us to encode binary data. Alright, this helps encode binary data. Okay, so we import crypto. We import AES from crypto, then from crypto. So meanwhile, you need to install you need to install pycryptodome. All right, so for you to import this crypto, for you to import this AES from crypto, so you can run pip install pycryptodome. All right, so but I've installed that already on my system, so we need to do that. Cipher import AES. All right. Um, so this is used. Okay, this is used to. This is imported from pycryptodome AES class. All right. So the next one is to import pad from crypto. Crypto.Util.Padding. Import pad. Then let's import JSON. Alright, so JSON is used to print and handle JSON objects properly. So you can also import login in case you want to debug. So this is used to debug. Alright, so login. So these are the dependencies we need to actually encrypt data. So the second part of this is to now derive our AES key. So I'm going to derive the AES key. The function derive AES key token bytes. Then if not token, raise value error. If not token, raise value error. Token cannot be empty. So this ensure that we have a token. Alright, so okay, else return token. And we also make sure that we remove every white spaces from the token. So I'll be using strip off any white spaces. So AES underscore key equals to hashlib sh 256 code. JWT 8 digest. Alright, so then let's return our token AES key. Alright, so we are returning our AES key ID, not token. So now this function is used to derive our AES key, and then it takes a token as a parameter. Alright, so also I remove white spaces and hashes it using SAH256. So the second part now is to now derive the initialization vector, that's the IV derivation. So I'll also write a function to do that. Derive AES IV token string bytes. So we have similar line of code. Is value token cannot be empty. Alright, hash SHA 256 return code TF8 X digest IV string equals SQ. So I'm going to explain this right. Um, just follow the process. Extending IV bytes equals IV string return code TF8. So if length, I need to check the length, IV bytes is not equals to 16, then raise value error, derive IV must be 16 bytes, else return IV bytes. So we have derived our initialization vector, which is the IV. So the AES in CBC mode requires a 16 byte IV, that's initialization vector. So we hash the token, convert it to X, then take first 16 characters from it. So this method is simple but ensures consistency. So the same token always gives the same IV. So the next part now is to write our encrypt field logic. So that will be done in another function. There's encrypt field, then plain text, then string, the key, bytes, then IV, and bytes, return a string. So put this inside a catch. Usually try and catch block cipher equals AES dot new key dot new key AES dot CBC ID. Then let's start the plain test. So padded plain test equals to pad plain test. So AES plain test plain test dot encode UTF-8. Alright, then AES dot block size. Alright, so the next variable will be cipher test equals cipher test bytes. So let's use bytes here. Bytes equals cipher dot encrypt, and let's encrypt the padded plain test. So padded plain test, and encrypted is 64. So now let's convert this to base 64. So base 64 dot b 64 encode cipher. So we are coding it now. Let's decode UTF-8. So we can now log it. Alright, so you may choose not to log it, but for debugging sake, so we can log and you may not log. So let me just do that in this tutorial. So log the debug. So I need to write the log equals to login gets local underscore name. So I need to install login. So this is used to debug. It makes it easier for you to detect where the error is coming from in case there's an error. Alright, error encrypting field plain test. Okay. Oh, let's log the encrypted plain test first before logging the error. So let's convert this to encrypted. Encrypted plain test. to encrypted data, encrypted 64. Alright, so it's good. So you may not use this, so it's just good for debugging. Then return the encrypted p64. Set exception C. So convert that to variable. So then log error. Of error. Since this is used for to detect if there's defaults, if the logic is finding it difficult to encrypt the data, then tests. So, then get the actual error. It's a G. Right. Okay. So let me explain this function so far. So in this function, we initialize an AES cipher in CBC mode, then also apply the PKCS padding so that the data fits the 16 byte AES block size. So, and also we encrypt, and then this 64 encode so that we can send a cipher text in JSON over the HTTP. So, and also we log the errors. All right. So the next part is the we need to check um, if name is equal to name. All right. If underscore name serialization is equal to underscore name, JWT token. Let's get the JWT token. JWT underscore token equals. So we'll put our token here. So we can log this also as well. Dot info. Alright. Using JWT token. Okay. So this block runs only when the script is executed directly. So, alright, so this is good for testing, and also I created a variable to get the token. Then I also logged to see the token. Alright, so I logged the token on the console. So then let's declare some variables here. AES key. Then let's call our function. So we are going to call the function we created the other time. Then derive function that we created. So pass the JWT token there as the variable. So then also the AES IV as a variable. So we pass the JWT and the derive AES key as a parameter. So because if you remember when we are declaring the defining this function, we pass a parameter, token parameter. So we do the same thing for the IV to pass the JWT token as well. Then you can log the info. You can log this info. Derive AES. Okay. Just AES key. Alright. Just steps. Alright, so let's do the same thing for the IV. So let's log the IV info as well. Derive AES IV. Derive IV. Just copy and paste. Pardon me. Alright, so now let's pass our the what's it called, the payload. We want to use the plain text that we want to encrypt. Alright, so I'll be using a login information as an example in this tutorial. So plain text payload first. Let's show email my email at example.com and password. Then my password. Alright. Oh, sorry, this is not the bracket I'm supposed to use. Okay. Okay, so we can log this in. Can log this as well. I'll log the plain text, but I will not do that. So let me just get the encrypted payload. Alright, so encrypted payload. Post this. So for key, so using for loop here. In field value underscore field plain text. So I'm checking for, I want to encrypt each of the fields. So we have two fields here. We have the email field and the password field. So checking for this same plain text payload dot icons if stands value field. So we are accepting all these strings here. So checking if it's a string, then encrypted payload field is equals to encrypted field and value field is key and is else encrypted payload key field equals value field. All right. So that's all about this. So now we are done with our logic. So we need to run this on the terminal to see our encrypted data. Run code. Oh, got an error. Okay, token cannot be empty. All right. So we need to get a token. So in this tutorial, I will not use the normal regular token that you may be familiar with. So I'm going to use I'm just going to put a string of 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll be using this as a token. Then let's run again. Oh, I'm getting an empty terminal. Right. Okay, I think this is something. Okay, for us to be able to see this on terminal, we need to write what's it called now? A login variable that enables us to see this on our terminal. So just add that here. So login dot basic config. So login dot info informatics clients. Alright, then name. Okay. Alright, so this will allow us to see the log, to see our encrypted data and on the terminal. So I will run this command again. Wow. Yes, okay. So now you work. So okay, let me add log.info. Let me add this so that let me just log this on our terminal to encrypt the data. Okay. So let's run it again. Wow. So now you can see our data is encrypted now. So the email and password is encrypted successfully. So this is how to encrypt data in Python. So and that wraps up this tutorial. So you just learn how to encrypt individual fields of a JSON payload using AES in Python. So thank you for watching this video. You can subscribe to this video and like this video and share. So in the next video, I will be showing you how to decrypt this data that we just encrypted. Alright, using the same token. Thank you for watching this video. Goodbye.